So what I did for SLT5, after we figured out where the shadows are going to be, if you just go literally straight down on the ground, right below the seat positions, that's where all the shadows are going to be. So that's how you can figure out where they're going to be. But what we're trying to determine first is horizontal distances, okay? So let's say, for instance, I'm looking for the distance from the vertical purple line here to the shadow of seat A, which would be right here, okay? So in order to figure that out, I have to look at this distance and recognize that it's the radius of my whole circle from the center to the point on the circle, right? So that would be the same distance to the shadow. That's 25 feet. So that is how I'll know that that's 25 feet. Now for seat D, I notice, let's go back, that shadow would be right here on the line. There would be really no distance between them. So that's why that would be a distance of 0 feet. Now if I wanted to figure out that distance from seat G, it should be the same as A. If you notice, it's the radius length, 25 feet. But the only difference is that distance is to the left of the vertical purple line. Because we can't write negative 25 feet for this, because we should not ever measure that distance negatively, we're going to say instead, let's go back to this, we're going to say instead 25 feet to the left. I'm going to write 25 feet. Target that here. Yeah, underneath I'm going to put to the left, because that will indicate it's a negative distance technically, but we can't write it. So we're going to say to the left to acknowledge it. So to that point, you can also say, when it's to the right of the vertical purple line, you can say to the right. If you notice, seat J overlaps seat D, so that means that will too have a distance of 0 feet. Okay? There won't be any difference there either. Okay? So what we want now is the distance from the vertical purple line to the shadow of seat B, which is right here on the line, on the ground. That means we want this distance of X, we're going to call it, right here. This is 25 feet. We recall from our prior Ferris wheel demonstration, there was 10 spokes. We're not going to count D and J. If you recall, D and J weren't on the Ferris wheel before, so we only had 10 seats. We know there's 360 degrees in a circle. So that means there's going to be an angle of rotation of 36 degrees per seat. That's how I know this is 36 degrees. So if I'm looking for side X and I pay attention, side X is adjacent to 36 degrees, my reference angle. Cosine is the ratio that I should go to, because cosine puts adjacent side over hypotenuse. So here's how I would set it up. This is for seat B. Solve for side X. You want to multiply cosine of 36 degrees by 25. Okay. Next, you go to your calculator and you type in degree mode, 25 times cosine of 36, and you should get your horizontal distance from the vertical line to the shadow of seat B at 20.225 feet. So we'll write that in, but we will acknowledge that it is to the right, since it's to the right of the vertical purple line. Now if I look at my Ferris wheel closely, I notice at point F, like B, its shadow has the same horizontal distance from the vertical purple line as seat B does. So it'll be exactly the same if you look at these distances here and here. The only difference is this is to the left of the vertical purple line as this was to the right. So you want to acknowledge that, okay, when you write this. So this is also 20.225 feet, but instead of saying negative, you're going to write this. You're going to say it's to the left. So that's the key. You want to acknowledge the fact that if your horizontal distance sits to the left of the vertical purple line, please write the words to the left after you find your distance. If it's to the right of the horizontal line, of the vertical line, write to the right to acknowledge what side of the vertical purple line you are on, so that we're accounting for that distance as knowing it to be a positive distance versus a negative distance.